Hey there YouTube, this is SJM4306 back with another project video. Yes, I said project video, not review video. I am slowly getting my lab together. Today I just found my soldering iron, so I can actually solder again. Oh wow, okay, yeah. That was like one of those things. I know I packed it, I didn't know where I packed it, and it was like literally in the last box that I unpacked. Anyway, so yeah, so I have the lab coming together, not so great. It's still like a lot of random junk. You can see all the junk that I have all over my desk. Anyway, today we are going to talk about an idea for a project that I got because I saw a couple videos online. People are making, I believe they're called the sisyphus tables, or however you pronounce that. Anyway, it's basically the Greek mythology thing of the dude pushing a rock uphill, like only for it to roll back down for all eternity. Anyway, for some reason they equated that with sand tables, with a steel ball that moves around with sand, and it can draw patterns, and it's basically an upside down 3D printer with, instead of the hot end, there's a magnet, and on the other side is a steel ball. So that's generally how that works. I have some sand here. This is pretty coarse sand. It's like just crafting sand. So I'm gonna pour a good deal of this out because I kind of did too much, and just sort of give it an even layer. And I'll show you the general concept. So here I have a little steel ball bearing, little tiny one. You'll notice that unlike the videos I'm alluding to, they use like fairly large mechanical systems. It's, you know, like it's a table. I want to make a tiny one, and that'll be my innovation. Pretty much the only innovation is just that I'm making a tiny one. Namely because I do have room now for like a giant table, but I don't want to have a giant sand table that's just in the way necessarily. I want this to kind of be like a desk trinket that you just plug in over USB, and it draws like tiny little intricate sand drawings. I thought that'd be really neat. So anyway, I've seen lots of people, like everyone makes like the large full table sized ones. So I don't think I've ever seen anyone make a tiny one that's like this big. So just as an example, I have some magnets here. You can see I'm not even touching the bottom of this, by the way. It's just a little off the side. And you can draw like patterns, and it's basically like an Etch-a-Sketch but with sand. And to erase it, most of them will just kind of do a zigzag pattern, and that sort of does erase it. I also had the idea of, to erase it, just have some vibration motors, like a cell phone vibration motor, and it just like, you know, just sort of, and then flattens it much quicker. So anyway, that's generally the idea. I don't think this sand is going to be appropriate. I'm going to probably need much finer sand because everything is being scaled to much smaller sizes. And you might have seen when the steel ball was skittering around a little bit too fast, it would sometimes get stuck and fling some of the sand around. So yeah, probably going to want something much finer, powdery. Something like, I don't know, like powder, like salt or something, or flour, but preferably something that doesn't possibly rot or decay or anything like that. But no, yeah, figure good enough to have like one of these small neodymium magnets and this steel ball, and that's sort of the size range I'm shooting for, something like about yay big. So how are we going to actually drive this? I took apart a lot of DVDs and stuff like that, and I'll show you in a sec. A long time ago I built it was basically going to be a tiny 3D printer, and the project just never got off the ground, and I have some of the mechanics working, and it was actually pretty cool. It was supposed to be like a plotter or 3D printer or laser burner. I don't know. I wasn't sure at the time when I made this, like maybe 4 or 5 years ago, what I was going to do with it. But yeah, I took apart lots of DVD and CD drives to get these motors from. So let me take you over to the desk and show you exactly what I built back then, and possibly how that'll relate to this project. Okay, so here we are. I used some pretty thick plexi, screwed everything in with some like erector set parts. These are just literally like the entire sled mechanisms for these DVD drives. I had one that does the Y movement, the other one does the X movement up here. The wires I soldered to each of those motors, as well as the end switches, because CD and DVD drives actually do have a little switch for the homing position as well. And so I designed a little sort of controller card. It's basically an Arduino Nano or Uno, whatever, ATmega 328P running the Gerbil firmware, and that's basically the G-code interpreter. And it controls these easy step drivers, and there's one each for each of those motors. And I was going to plan some more circuitry if I wanted to put a Z-axis or a laser diode or whatever, but I never really got around to that. This does work. If you hook this up to Gerbil, and you actually send a G-code, both axes do actually work, but I just never really got any further than that. I don't know why. And all this is, this is, and there you go. It's all point-to-point wired. It's sort of, how you doing? So yeah, this project kind of went nowhere. So I was thinking about this, last few years, thinking, I kind of should do something with that. So I was thinking of actually repurposing the mechanics of these, or maybe even the worm screws I had on the table there, to make a little XY drive that I could mount the magnet to. So let's go back to the bench. Okay, so yeah, basically my idea was maybe I'll take two of these motors. These are little worm screws. I can add a little, like maybe a spring or something like that that goes in between the threads that it can then push back and forth with like a little carriage. Each of these drives usually comes with two linear rails. I could 3D print little bushings for those. That's not a big deal. I could have one of these be X and one of these be Y. So one of these motors would have to move up and down, and then the magnet would just ride along that track. So that would give me my XY. And these are fairly high resolution, because if you think about what they're actually doing, they're coarsely adjusting the position of the laser head, but it's still actually pretty fine work. So you get pretty decent accuracy out of those. Definitely more than enough to push around a little tiny steel ball into sand. But yeah, I was thinking, yeah, that would be, in that case, like the wiring and everything would be pretty simple. Mechanics might be a little bit more annoying. But I've been also reading about a really interesting method of controlling 3D printers, and that's the Core XY. So if I did it with these two axes, this would basically just be standard Cartesian. So it would be X motor, Y motor. But the Core XY works very differently, and I actually had, from my reading of it, it kind of confused me. How the heck does this work? Because two of the motors are actually mounted vertically on the end side. And so these motors are tiny, not particularly beefy. They won't go super fast or anything. Not that I need this to go fast. But I kind of would like to use easier to get motors that are cheaper too. These little 28 BYJ 48s, and these are 5-volt stepper motors. And the good thing about these are, so these worm screw motors are bipolar. These are unipolar, which means basically just that they have an extra wire that connects to the center taps. And electrically, what that means is you can drive these with like a simple totem logic kind of output sort of thing, like using a Darlington array. And so these are actually really easy to sequentially step through in software. So basically I wouldn't need like a stepper motor driver. I could effectively make my own really cheap ones for these. And I noticed that, okay, say I want to make it, the draw area about yay big. These motors are pretty big if I wanted to use them in like an XY regular Cartesian orientation. But if I have it mounted in the Core XY mode, I could just put them upright and then drive little pulleys with string that connects, or some kind of tiny timing belt that'll connect the mechanism. And so if I mount them like this, just under the sand sort of area, it's pretty space efficient. And so I really like this idea, and these have more than enough torque, and they have a decent enough resolution for what we're trying to do then. So I would like to use these, because these are like, you can get these anywhere. You can also get these worm screw things, but they're more fiddly, and they're usually pulled from CD and DVD drives, and of questionable origin. But these guys you can get really cheap. They're like everywhere, and for many years to come, I have a feeling these are just going to be available in pretty large quantity. Plus, those are cheaper generally than these little worm screwy things if you wanted to get ones with the actual like sliding block mechanism and everything. If you just want to get them bare like this, they're cheaper, but it's more work. I want to do less work. So anyway, to understand how Core XY works, I actually dug out my old Lego set from when I was a kid, and I made a demonstration mechanism, and this made it really actually intuitive how this works. At first I was a little bit confused. I kind of generally had the understanding that these two motors, in order to go in a straight line that was either vertical or horizontal, they had to work in tandem. If you only drive one of the motors, or you drive them not proportionally, you get different effects. I'll show you in a second what exactly I mean by that. So the easiest thing, say if I want to drive this left, right, so you'll see these two pulleys. Pretend these are the motors and watch the directions they turn in. When I go to the left, they both turn counterclockwise. When I go to the right, they both turn clockwise. So if they're turning at the same rate in the same direction, you're assuming this is like your print head or your magnet, will go exactly left or right. So that's actually pretty cool, pretty intuitive. So then how do we get the whole bed to go up and down, for instance? Well, watch what happens now when I pull this down and push this up without moving the head left and right. So you might notice now those motors are moving in the opposite direction. When I push this up, this one moves counterclockwise, this one moves clockwise. And when I pull this down, it's the exact opposite. This is clockwise, this is counterclockwise. So by using this sort of H-shaped orientation, you can reposition the motors to kind of a more favorable mechanical sort of thing. It's at least easier for me to manufacture something like this. I could 3D print a base that these motors just screw right into, and that's all easy peasy for me. And all I have to do then is control kind of these two legs. And to get any motion that's not either purely vertical or horizontal, you just change the rates of speed of the left versus the right motor. So you can get these to go diagonally, or pretty much in any shape, in a circle if you want, whatever. So it's just a matter of controlling these two motors' relative directions and speeds. I thought that was actually a pretty neat thing going on there, and this makes it a lot easier to understand something that I can physically pull these strings on and see exactly what's happening. So I kind of want to go for Core XY. I think in general that might be easier to like 3D print a base that doesn't require specialized hardware or anything like that. I will still need linear rails and everything, but I won't need these kind of semi-specialized worm screw things. I can just use like pretty much any motor that's can be right angle mounted. And yeah, so I think I'm going to go Core XY. That'll complicate the software a little bit, and that's kind of the other thing. So I'm on the fence. Do I want to go the same route that everyone else does, which is you just download Gerbil and then you have a Raspberry Pi? And so you need two processors then. You need, an ATmega, one of these little guys, to actually do the G-code interpretation, but then you also need a Raspberry Pi that sits there and just feeds it G-code to draw the different patterns. That's great and all, and I might do that. I'm tempted to, because honestly that's already all figured out. All the work would be done for me. It would just be a matter of burning the image to an SD card and configuring it. Or do I want to just have one controller, for instance, like the 2560, the ATmega 2560 that I've been using, or possibly an RP2040, because I get plenty of flash, plenty of RAM in that case, and implement everything all in one. So my idea was have a little OLED screen and a little joystick on the side, so you can manually select what you want it to draw, or just set it to like shuffle basically. And So have the ATmega both sending the G-code commands to the motors to manually spin them correctly, as well as do the user interface and have an attached micro SD card slot so you can upload your own G-code. Now I'd have to implement my own G-code interpreter in that case, as well as the motor driver kind of software, low-end function, lower level functionality. And so that'd be a little more complicated, but I can get really creative with how I implement everything in that case, because it'd be 100% controllable by me with just a single processor. Also, another thing that I'm thinking of doing is, of course, RGB lighting around the sand pit area so that you could set the color or could have it, slowly fade or whatever you want. So these are generally just ideas I'm throwing around. I'm thinking like a small cube sort of thing, about yay big, yay high, that you just pour sand into, has like a little glass cover just to keep the dust out. And you just, if I can get it quiet enough, which these motors, if you have them turn slowly enough, they'll definitely be pretty quiet. And just running all day, just plugged into a USB port and just keep drawing different patterns and stuff like that. So that's sort of my idea. I've rambled on for a long time. Sorry about that. I have so many ideas, and I just wanted to get them out there and to get your your people's opinions. Anyway, and that kind of brings me to the last kind of bummery bit of this story. So, as you guys might have known, I used to be, I'll just come out right and say this, I used to be sponsored by JLC PCB for all these sorts of projects. They would not only provide me with PCBs, but they'd provide me with basically like a stipend so I can actually buy the parts and assemble these things. So yeah, as of it was like towards the end of last year, they contacted me and told me, sorry, but we can't sponsor you anymore. So unfortunately, that means that I'm in kind of a tough spot. I just bought a house. Like, pretty much all my savings are wiped out. Houses aren't cheap. And I've been saving money for like almost a decade, and just all that went into the house, almost all of it. Anything left, I have to pay bills. I have to pay my mortgage now. So things are a little bit tight financially. And so I'm also not getting that sponsorship, that advertising money that I'm usually getting. I do have some savings in terms of like YouTube ads, but not really that much to go crazy on projects like this. So I'm gonna try my best. I'm gonna see if I can work something out, maybe with another PCB manufacturer, go back to JLC and try to sell them the idea if they want to sponsor like a one-off video or something. I'm gonna see if I can get funding. If not, I might have to, I know, I might have to resort to some kind of crowdfunding thing, because yeah, I don't have a lot of spending money right now. PCBs are pretty cheap, but I don't know how many iterations I'm gonna need for prototyping. And it's really difficult making this kind of stuff when you have to get it right the first time, which is never going to happen realistically. So yeah, I'm going to do the best I can. If you guys wanted to throw in anything, like I have PayPal donation link in the video description. I've had Patreon for the longest time. So if you guys wanted to throw a few bucks towards this project, you're absolutely not obligated to, but I would be very grateful if you wanted to do so, so that I can get some prototyping going on this project. If this is something that you're interested in, if it's not and you don't want to put any money for this, I absolutely understand. But yeah, that's just a reality of what the situation is. Yeah, I'll be honest, like, this channel did amazing when COVID hit because everyone was staying at home, and then as soon as that, everything opened up again, my channel, just subscribers and viewings tanked like pretty hard. And so realistically, that's generally what happened. And I do not, just let me get this off my chest, I don't blame JLC PCB one bit. Like, they're doing what's best for their business. They have a lot of other much larger, much more successful channels to sponsor. So I 100% understand what their position is. But I also need I just have the need to make this stuff. Like, I have just random ideas inspire me, and I want to make them a reality. It's just now the trouble is finding money for parts and prototyping, as well as time, because commuting about like an extra hour and a half a day. So less free time on weekdays. So all I got on my weekends right now, pretty much. But yeah, we'll get through this. Hopefully things will settle down on the channel, and we'll start getting that positive upward trend again, and get that sweet sponsorship money. Anyway, yeah, sorry about rambling and kind of being a downer at the end here, but yeah, just wanted to let you guys know what the situation is, and that I am 100% committed to continuing like random crazy projects like this. But like, yeah, it's gonna be slower if I can't manage to get help on some of these parts. But yeah, anyway, if you guys have any specific suggestions on where you see, you know, a tiny little sand table project going, what would be kind of the best way of doing things, different ideas I haven't even thought of maybe, please put them down below. I'm actually still in, obviously I'm still in the very crude prototyping stage. So yeah, just let me know what you guys think, and I will see you in the next one. Bye.